Very good morning, students. I am Professor Prakash Rokde. Today we will learn sequence diagram, which is the part of Unit 3 from Software Design and Modeling. Now, this sequence diagram is behavioral type of diagram of UML. You all know UML, that is the Unified Modeling Language, are divided into two fragments: structural diagrams or physical diagram and behavioral diagrams. So your sequence diagram comes under behavioral diagrams. This sequence diagram captures the interaction that takes place in collaboration that either realizes a use case or an operation. High level interaction between user of the system and the system, between the system and other subsystem, or between the subsystem. These interactions are shown by your sequence diagram. If you see the context, it clears that purpose of the sequence diagram is to model high level interaction between active objects in a system. It models the interaction between object instances within a collaboration that realizes the use case. It models the interaction between object within a collaboration and realizes an operation. Either model generic interaction. Sequence diagram shows elements as they interact over time, and they are organized according to object horizontally and time, that is the vertically. Object dimension, the horizontal axis shows the elements that are involved in the interaction, and the time division, the vertical axis represent time proceedings are progressing down the page. Time in a sequence diagram is all about ordering, not duration. The vertical space in an interaction diagram is not relevant for the duration of the interaction. You can see object and its role. So here the participants in the sequence diagram are object or roles played by the actor. Objects are the basic elements in sequence diagram. The exchange of messages takes place between objects or roles. Roles can be played by human users, external hardware, or other subjects. An object in a sequence diagram is rendered as a box within a dashed line descending from it. The line is called as object lifeline and represents the existence of an object over a period of time. Now see, in the next object lifeline, it clears that it's a name element which depicts or shows an individual participant in a sequence diagram. So basically each instance in a sequence diagram is represented by a lifeline. Lifeline elements are located at the top of a sequence diagram. The standard UML for naming a lifeline follows the following format: instance name and class name. Now see, here instance name is X and class name is the 1. Next is your message and stimulus or stimulus. Communication between object is shown using messages. The messages appear in a sequential order on the lifeline. Messages are represented using arrows. Lifeline and messages from the core of a sequence diagram. Messages can be broadly classified into following categories. Now see, here the categories of messages are shown. So first is the synchronous message, asynchronous message, create message, delete message, self message, reply message, found message, last message, duration message. Now the very first is the synchronous message. A synchronous message waits for a reply before the interaction can move forward. The sender waits until the receiver has completed the processing of the message. The caller continue only when it knows that the receiver has processed the previous message, that it receives a reply from message. Then a larger number of calls in the object-oriented programming are synchronous. A solid arrow head is used to represent a synchronous message. You can see here user and device. User sends the message open application, and device reply, and it acknowledges that application is opened. Asynchronous message. An asynchronous message does not wait for a reply from the receiver. The interaction moves forward irrespective of the receiver processing the previous message or not. A line arrow head is used to represent an asynchronous message. Here you can see sender is there and receiver is there. Sender sends the message, asynchronous message, actual parameters. Then next is your create message. Create message is used to instantiate a new object in the sequence diagram. There are situations when a particular message call requires the creation of an object. It is represented with a dotted arrow and create word label on it to specify that it is the create message symbol. You see the example, the creation of a new order on an e-commerce website would require a new object or order class to be created. Now here user, new order, and creating a order class through new message that is shown. Next is your delete message. Now delete message is used to delete an object. When an object is deallocated memory or it is destroyed within the system, we use delete message symbol. It destroys the co-occurrence of the object in the system. It is represented by an arrow terminating with a X. You can see here, that is the crossbar. With that, delete message or kill. It is also called as kill. For example, the scenario below, when the order is received by the user, the object of the order can be destroyed. Then next is your self message. Now, this scenario arises when an object needs to be sent a message to itself. Such messages are called as self messages and are represented with a U-shaped arrow. You can see here self message. Next is your recursive message. A message defines a particular communication between lifelines of an interaction. So here recursive messages is a kind of message that represent the invocation of message of the system, same lifeline. It target points to an interaction on top of the activation where the message was invoked from. Next is your reply message. Reply messages are used to show the message being sent from the receiver to the user. A return or reply message is represented using an open overhead with a dotted line. Interaction moves forward only when a reply message is sent by the receiver. See, here is the sender and here is your receiver. So your reply message through dotted line is sent. Next is your found message. Now a found message is used to represent a scenario where an unknown source sent the message. Now it is represented using an arrow directed toward a lifeline from an end point. Now generally in the system this condition does not occur, or even when you are writing the answers for any question requesting to draw a sequence diagram, this kind of situation never occurs. So it is exceptional. Next is lost message. Now like your found message, this lost message is there. A lost message is used to represent a scenario where the recipient is not known to the system. This condition exceptionally comes, no need to write as a part of the answer in the final. It is represented using an arrow directed towards the end point from a lifeline. For example, consider a scenario where a warning is generated. The warning might be generated from the user or other software or object that the lifeline is interacting with. Since the destination is not known beforehand, we use the lost message symbol. Now see here, user, your device, user asks open application, then access webcam, then warning. Now this warning, where to go the warning? No one is there, object to accept the warning, so it simply, this is the lost message. Next is your duration message. A message defines a particular communication between lifelines of an interaction. Duration message shows the distance between two time instants for a message invocation. So here is your sender, receiver and message, and there is one, that is your duration message, this first message. Now you can see activation or focus of control. Focus of control here also called an execution occurrence or execution occurrence. Now it shows tall, thin, rectangle on a lifeline. It represents a period during which an element is performing an operation. The top and the bottom of the rectangle are aligned with the initiation and the completion time respectively. This is the diagram to show activation focus of control. Now these are some of the operators: alt, opt, par, loop, region, neg, ref, esd, and for that fragment type are shown. And you can see here it is possible to combine frames in order to capture loops or branches. Combine fragment keyword: alt, opt, break, per, sequence, strict, negation, critical, ignore, consider, assign and loop can be used. Constants are usually used to show timing constants or messages. They can apply to the timing of the one message or intervals between passages. You can see here order, distributor, messenger, your operator, guard, alt, all those things can be shown in this your sequence diagram. So this is all about your sequence diagram. In the next lecture we will see the collaboration diagram, but at home you may draw the sequence diagram for railway reservation, hospital management, hotel management. Thank you very much.